There is no tool for an investor more useful than Wright's law. Only with Wright's law can you accurately predict the future of... Hold on, you've heard this before. I'm not here to sing the praises of Wright's law once again. No, I'm here because I was watching my video about how to think like Kathy Wood, and when I saw the formula for Wright's law, I couldn't help but think, Ghost, you've studied mathematics at an advanced level. This can't seriously look right to you. So I gave it some thought, and then gave it some more thought, but I still couldn't figure out what was up with it. But, as I'm glad to say, I have figured it out. This is ARK Invest's Wright's law formula explained. Now, to clarify, Wright's law itself is perfectly intact. The idea that for every cumulative doubling of units produced, costs will fall by a constant percentage remains true as ever. My problem lies with this: y equals ax to the b. Where I was struggling was with b. ARK gives this as the slope of the function, which to me sounds like it should be dismissed as nonsense. However, if we describe it with the more formal definition of the derivative of the function, we find that surprisingly this actually has legitimacy. So long as b is negative, the formula works. We can demonstrate this, as we can see from these examples. For every cumulative doubling and reduction, costs do indeed fall by a constant percentage. But there is still something wrong here. See it? b is a constant, but the slope of the function is not. However, there is a solution. If we look at any useful examples of Wright's law, you will notice one thing. The axes are always using logarithmic scales. Indeed, you will also notice that with the data in logarithmic form, the trend line is now linear. And what is the gradient of this line? Why, it's b. Now it makes complete sense why ARK would use this form of Wright's law. After all, the law is only stating that there should be a linear line of best fit for a logarithmic price against logarithmic cumulative production. As such, y equals ax to the b is the easiest formula to extract from the data, as a and b are now both trivially easy to find. One small aside, I don't for the life of me know why ARK states y as the average time or cost per unit, when simply the time or cost of the latest unit makes more sense and is much more useful. Do let me know if you have a sensible explanation. Back to it though, one useful thing still remains to be calculated: the actual constant percentage by which costs fall. Something that people call the learning rate, discount rate, or improvement rate. The important thing to note about this is that the improvement rate is not time dependent, but instead dependent upon quantity, be it cumulative number of units, cumulative watt hours of energy storage, and so on. For a graph with the x-axis in log base 2, the improvement rate is still trivially easy to find, and it's still relatively easy to find in any other log scale too. However, I want to create a formula for Wright's law in which this improvement rate is explicitly part of the equation, as I believe this is more useful for investors and analysts. This formula is also exceedingly simple: y equals ax to the log base 2n. In this formula, x equals 1 minus the improvement rate, and as such is always between 1 and 0. This means as n increases, the cost of the latest unit decreases. It's literally the same graph, just expressed in a way that I feel is easier to understand and is also much more useful. It is also a truer descriptor of the fundamental principle of Wright's law, namely that for every cumulative doubling of units produced, log base 2n, cost will fall by a constant percentage, 1 minus x. If you wanted, you could even leave the improvement rate in there. I prefer not to, but that's up to you. In any case, I find this version of Wright's law to be much more useful, as using the slope of the function generally requires you to have a graph to hand, while simply having the improvement rate avoids such requirements. As such, I find it a lot easier to compare the single number of improvement rate than it is to compare the slope of entire graphs. Perhaps that's just me though. Anyway, I hope this has been sufficient explanation of the Wright's law formulae. Do let me know which version you prefer in the comments. Also, if there are still things you'd like explained further, comment and I shall answer. Otherwise, I encourage you to subscribe, like, share, and generally do whatever else pleases the YouTube algorithm. Alright, that's all I have for this video. I'll see you in the next one.